In problem 36, we're going to be working with a jet that's flying through the wind, and we're given the vectors for both the jet and the wind. It's helpful to sketch off to the side your compass rose so that you know what direction you should be drawing your vectors in. It says the wind vector is heading at a speed of 55 miles per hour in the direction of north 30 degrees east. So starting in the northerly direction, we turn 30 degrees east, and that tells us where our vector will go for the wind. I'm going to go ahead and sketch a right triangle to match with that wind vector, and that will help me break it down into the horizontal and vertical components. And then finding those two components is similar to converting to polar coordinates, to rectangular coordinates. We have an angle to work with, and we have an r value to work with. And so the x value can be found by taking 55 times the cosine of that angle, 60 degrees, and then the y value is found by taking 55 times the sine value of that angle. These are the two values that I get when I do that calculation. Make sure your calculator's in degree mode since our angle is given in degrees. And so that gives us the component form of our vector, both of our wind vector, the horizontal and the vertical components. Next, I'm going to go ahead and sketch the jet vector. This is heading in the same direction, north 45 degrees east, just at a slightly different angle and a much different speed. Again, I'm going to draw a right triangle that coordinates with this vector to help me break it down into the horizontal and vertical components. And use the same method. In this case, since we're talking about a 45-degree angle, our horizontal and vertical components should be the same because that creates an isosceles right triangle. And so that gives us the horizontal and vertical components of our jet. The last thing to do is to find the true velocity of the jet. And all it says is in vector component form. It doesn't say we need to find a direction or heading. And in this case, both the wind and the jet are heading in the same direction both ways. Both of them are heading north, both of them are heading east. So we don't have to do any subtracting in this case. Both forces are working in the same direction. So we just need to add together both the horizontal and the vertical components to get our final resulting vector. And so this is the horizontal and vertical component of the jet after we account for the fact that the wind is pushing forward and adding to its speed.